Okay, so we're going to continue with what we left on the recursion. So again, recursion is chapter 12, as we said earlier. I'll go through some of the theory here again, so hopefully we get it right. So I already posted a slide also in the Canvas. So again, recursion is chapter 12 of this course, the course textbook. And as we said, the main definition for recursion is solving a problem by reducing itself to the lowest. So the recursion process is a process of solving a problem by reducing it to the smallest version of itself, or I just say by its lowest version of itself. And also we saw the definition for recursion on Tuesday. We also said that we can have what we call the infinity recursion. Infinity recursion is same as the infinity loop. As we said earlier, with recursion, we have two things we have to be more concerned. The base case will stop the recursion. So it's more or less like you have a for loop. The only way the loop will stop is if the condition is false. With recursion, the only way to stop is if we reach the base case. If the base case is true, I just write if it's true. And also we have to have our recursive statement. So this is the function that will be calling itself over and over again. As we said earlier, also we can have more than, I just write greater than one, more than one base case, but the recursive statement have to be only one. So again, that's the whole concept. Infinity recursion, same as infinity loop. If the base case can never be reached, or it will never, the condition will never be true, then we are going to, again, call the function over and over till, so it will be infinity. And I think we saw this example on Tuesday, which is a recursive factorial. I'll wait for a few seconds if the concept is okay. Or this is how it works. For example, we are looking for a factorial of 4. We can see the recursive statement here will be the second statement where we have, so the function name, here I'm assuming the function name is factorial. So factorial of n will be n times factorial n minus 1. So if it's 4, it will be 4 times 3 times 2. Again, the function will be calling itself. So this is how the whole thing will work. Factorial of 4 will be 4 times factorial of 3. So this is why we say recursion, kind of there's small overhead, the overhead cost in recursive, because every run we have to call the function, and also we have to update the argument, the parameter of the function. For example, it was 3 now, it should be 2. Then it's going to be 1. So the function is calling itself updating the parameters. And that's the concept here. In this case, our final answer will be 4 times 3 times 2 times 1. But the whole goal is, this is where our condition met. 1 times factorial of 0. That's why our base case, the base case, I will say the base case is I'm using the term condition. So when we reach here, factorial of 0 is 1. And then we stop calling, the function will stop calling itself. So basically we do the arithmetic together again. Whatever it is, it should be, let's see, it should be 6 or 24. Yeah, 6 times 4 is 24. So this is how the code works. So we can see the base case said if n equal to 0, return 1, because factorial of 0 is 1. Or I can say if n equal to 1, return 1. Why? Because in mathematics, factorial of 1 also is what? Is 1. Or I can have both conditions there, which is unnecessary, but I can write if num equal to 1 or num equal to 0, then return 1. Because again, it's the same as factorial of 1 is 1, factorial of 0 also is 1. Then the recursive statement said num times what? Fat num minus 1. So here the function will call itself until we reach num equal to 0. So that's the whole concept here. Let's wait for a few seconds if it's okay. Again, we have the base case, num equal to 0. That's always the base case will be the smallest unit, or I'll use the terms, the the smallest version or unit. So if I'm looking for n equal to 5, of course, the lowest n will be 0. We don't go negative value. We cannot find a factor of a negative value. It has to be positive value. And normally it will start from 0. It will start from 0. Also, we went through this example again on Tuesday. And we also saw this already. So I'm going to skip all this. The only thing, we have some code here, which we went through the sum. If we look at the sum, it's almost the same as a factorial. The only thing, we have a plus now. I'm looking for a sum of number, let's say n. N is 5. So I'm looking for 1 plus 2 plus 3 plus 4 plus 5. So the lowest unit again will be 1. So we say that, okay, if the number equal to 1, of course, then it's 1. Otherwise, we had the number plus. We start with the highest. So recursion will opposite. So it will be 5 plus 4 plus 3 plus 1. So that's the recursive statement. First, we have 5. So it will be 5 plus 5 minus 1. Call itself 4 minus 1, 3 minus 1, until the condition is true. Also, I think we went through this code already. And we also talked about the direct and indirect. So I want us to go through one. Again, we don't have time right now. So I want us to go through this code. The reason why we should go through this code, here we will see that we have 2 base case instead of 1. So to find the Fibonacci of a number means the 2 previous values, you add them together. So if I have a Fibonacci of 0, the answer is 0. Fibonacci of 1, the answer is 1. So there's difference between 0 and 1. It's not like a factor of 0 is 1, factor of 1 is 1. So here, the condition is given here to find a factor of a Fibonacci of a number. We say, okay, the first value, because the first 2 previous value will be different. And from third going, it's easy now. So if I have a number, only 1, Fibonacci of 0 is 0. There's nothing here. Fibonacci of 1, still 1, 0 plus 1. But there's difference now. 0 is on. So this is why we are going to use this as our base case. Then from 2, 3 going is easy now. I will take the 2 previous, add the 2 previous values. So that's what we are saying in the second condition here. If n is greater than 2, from number 10 going, if I have more than, then what we do, we had 0, 1, and the previous n minus 2. So if I say 0, let's say a is 0, the first value. Let's say I'm here, so I'm going to add this 2. That's what I'll be trying to say over there. And this is how the code works. So we can see if n equal to 1, return a. If n is equal. Now, n is not, we are looking for the Fibonacci of the number. So Fibonacci, this will be Fibonacci of 1, Fibonacci of 2, Fibonacci of 3. It's not the actual value. So if it's so that's what we mean by the base case. If I'm looking for Fibonacci of 1, then I'll return the first value, which most likely will be 0. Or if it's 2, then I'll return the second value. Other than that, again, we had the 2 previous value. So it will be AB n minus 1 plus n minus 2. The 2 n minus 1 is the next previous value, n minus 2 is the next previous value. So we had them together. So this is the code I want us to look. Again, because of time, we can't continue. We have only 4 minutes left. So what I'll do is that, again, on Tuesday, we shall go through it. We are going to have a lab work. Hopefully, we're going to have a class work also. So let me wait for a few seconds if any question. Again, because of time, we can't finish this.
Going to be for the midterm grade. Is that our final grade, or are you going to?
Oh yes, it's the final grade. Okay, maybe some of you are not here on Tuesday. So what will happen is that I don't give. I'll go by the syllabus. So no extra assignment, no caffeine. Let's go by the syllabus. So what will happen is that, again, I don't want to open the grade book, but when you go to the grade book, you see a section saying class participation something. So for example, you get 5, the maximum is 45. So anytime we do a classwork, you get 5. And what I will do is that I'll give the classwork in class. So a class participation didn't mean home participation. So if you are absent, I can't tell you do your class participation at home. Unless there's another option. If you can send me email from the student of Dean, they will excuse you. Actually, in that case, I will even mark you present. Some student get a letter. Maybe all of you know it. So, for example, if I mark you absent and they send me the letter from Dean of Student Services, something, absent, excuse absent, I will change it to present. So in this case, I'll give you the option to do the classwork if you didn't do. Actually, I even tell you to do at home and submit it. So just go by the rules of the school. As I said earlier, I'll try to go by the code of conduct, the school code of conduct. As a faculty, I'll try to follow my rules. If I make a mistake, you can report me to my supervisor. He will talk to me. I say, oh, sorry, I didn't know, it's ignorance. The next time I learn from that. But so far, I think I'm in the right path.
Yeah. What about the extra assignment?
Oh yeah, that one later I will add it to midterm or anywhere if I get chance. So the extra assignment, if you have the points already, I won't take it back. I already give it, so I will add it. So I'll add it to the mid. And also one thing I mentioned also is that, how will I say it? I will leave this for the next class. Yeah, this is perfect for me. Hopefully no more recording. So one thing I want to mention again is that, please, if you have a question, ask the question now. When I start to pack my bag, if you ask me a question, I will ignore you. Or I'll tell you, actually, I won't ignore you. I think that's the best option. I'll tell you, send me the question on email. The reason why, because I have a class at 11:30. Only this Tuesday, so I would say it's one of the first time I was not late in my second class. Because, again, that's it. So I'm going to ask you if you have any question. We have only 1 minute left.
What were they saying about the 10 points to be?
No, that's the extra. Yeah, I will add that one. Hopefully, if I get chance. Okay.
No way you could admit you. And there looks.
No. And so, if no question, okay, we see you on Tuesday then. Yeah.